Hello Homo sapiens! Today, because I've already taken you on a journey through the macroscopic world, I'm going to take you to the microscopic world. Everything very small, from bees, flies, mosquitoes, to atoms, electrons, and quarks. So, let's start with the average person, 172 centimeters tall. Hola. Let's shrink this person down to the size of a blade of grass. A fly that passes by would now be the size of a dog. And humans would be it would be very massive. The sizes of skyscrapers. Let's shrink the person down even more. Now the person is able to stand on the blade of grass. The fly that was buzzing around now looks like a helicopter. You try to escape its flappiness, but you can't because the air, it's like slime. When you were larger, the air resistance is barely noticeable. But now that you are very small, wading through the air is like swimming through honey, very thick. These creatures, flying insects, use this to their advantage because instead of trying to push through the honey, flies and bees and wasps would use them as paddles, like rowing through the honey. If we sized the insects to the size of humans, then they would be able to fly faster than planes. And planes fly really fast. Now, let's shrink down even further to the microscopic realm. Welcome to the microscopic realm. You are now the size of an E. coli bacteria, and you can see bacteria. The blade of grass that you are standing on is now a massive field of plates. Each of these plates are actually just cells, the cells of the grass. And every few cells, there is a special cell, a stomata with an opening. They are like mouths that open and close to make the plant able to breathe. A droplet of water rushes towards you like a meteor waiting to strike the earth. But you just get sucked into the meteor instead of being hit like a hammer. Inside, you see around there are multiple different types of microorganisms. There are eukaryotes, prokaryotes, there are several bacteria, archaea, and stuff like that. Now let's shrink even more. Welcome to the molecular realm. You are now the size of a molecule, and you can really see at this point that everything is just rippling and crossing over each other like waves. At this point, you can also see what heat truly is. When you are the size of a regular human, heat is just hot or cold. But then if you are at this size, heat is the speed at which molecules will bump into each other, the average speed. The colder something is, the less collisions will occur. The hotter something is, the more collisions will occur. And around you, as you escape from the water droplet, because it's not holding you very tight anymore, you can see that the air there is just filled with nothing. It's nothing sprinkled with a few particles. That means when you're breathing in, you're just basically breathing in nothing sprinkled in with a few particles. It's mostly just empty space. Let's shrink down even further. Congratulations, you have entered the atomic realm, where an atomic nucleus is the size of a grape to you. Around this nucleus is an area of influence about as tall as the Burj Khalifa. The atomic nucleus is made up of two things, which are the proton and the neutron. These can be cut in half to reveal up and down quarks. The area of influence is filled with electrons. Electrons are unpredictable. You can never tell where an electron will be. Instead, you can calculate the probability of an electron being there. So, an electron could be here, but it has a higher chance of being here. Each atom holds back the power of a nuclear bomb, and it doesn't let them sit still. So, atoms just wiggle around in place, jittering with all that energy being held back. And that's it for the atomic realm. So let's go to the smallest place. Ta-da! Welcome to the smallest place in the universe. You are now 1 Planck length. What is a Planck length? A Planck length is the distance that light travels in a Planck time. What is a Planck time? Planck time is the time it takes for light to travel a Planck length. Confusing, right? This place is completely unknown to people. We believe that this is the smallest that anything can go, and that particles will just bubble in and out of reality at this scale. This is the border of reality and unreality. So for now, this is the end. So I guess it's time to shrink back, reverse shrink. Ta-da! So this scale that we are now at is, you can call it the perfect scale. Not too big and not too small.